So I guess it's 10:15. I'm going to go ahead and get started. Welcome, everybody. My name is Ovidio de Jesus. I'm an SE covering the East Coast of the United States, focusing mostly on partners. So today I am going to talk to you about something that is kind of personal to me. When I first started working with CASP and CAP, I was very confused. It's like they look alike, but at the same time they're very different. So I was trying to figure out what it was. So I kind of went through the journey. I think I have a pretty good understanding of what they are. So that's what I want to share with you guys. What is CASP? What is CAP? How are they different? But at the same time, how do they complement each other? I do have to give you a heads up and apology. Been trying to get to my my server, but I guess they're blocking it or something. So I'm supposed to have a demo at the end, but I'm not going to be able to do that for you guys. So what we're going to be doing today is, a definition of what we're talking about today, which is CASP versus CAP. I called it versus, but at the same time, they do complement each other, and I'll get to that at the end. We're going to go into CASP. What is CASP? What it can do is kind of like a high-level overview. There's a lot of sessions here that are going to go a lot deeper into it. So if you guys are interested, you're welcome to go to those. Then I'm going to go into CAP. What is CAP? What does it do? What is Cloud Foundry? That was my main hang-up, understanding what is it that Cloud Foundry do. So I'm going to explain that to you. And then wrap it all up and just kind of bring the whole thing together, how they both work with each other and what they do best. And of course, the demo, I don't have the live demo. What I might do is I have some screenshots and I can show you how to install CASP, for example. So we'll give you something to take with you. So what are we talking about? This is a slide that you're going to see throughout the function pretty much all day today, tomorrow, and Thursday. This one shows everything that SUSE has to offer, starting at the foundation with the operating system and all the different levels that go on top of it, such as storage, OpenStack Cloud, SUSE Manager. We're working on the outside cloud, so on and so forth. Today, we're just going to talk about the top layer, which is what they call the developer layer. This is where developers work. They develop software, they develop applications and stuff, and how do they manage them, how do they put them out on the internet, on the web, whatever. So that's exactly what we're going to be talking about today. Specifically, as I mentioned to you before, CASP and CAP. So starting with CASP, they're both based on Kubernetes, but when you look at CASP, it's mostly for containers. How to manage containers, create containers, deploy containers, update containers, delete containers, and doing all that kind of stuff. So it's the best Kubernetes operator experience. So this is for people who are, like I said, just doing containers and how do they operate with them. Then we're going to go into CAP, Cloud Application Platform. This is based on Cloud Foundry, and it's more of a developer experience. So this is when you're developing an app, which is a little higher level than a container. For example, an app can have containers within it as part of the whole app. So it's what I would call a little higher level on the whole developer experience here. So let's talk about the why. Why are we talking about containers? Why are we talking about applications for the cloud? So it's still, but it's kind of like the old-fashioned way of doing things. You have what we call monolithic environments, where you have a bunch of programmers, and everybody, they do have different things that they do, but they all work together. So every time there is a change or something, they have to go through this whole process into the plan, the code, the testing. And sometimes, I don't know about you guys, but when I was doing some software development, sometimes I spent hours and hours sitting in meetings of stuff that had absolutely nothing to do with me. because my part of the software is not what they're talking about, but still I had to be at the meeting, I had to go through the whole thing. My code had to go through the whole testing phase and QA phase and all that stuff when it really didn't need to be. And what happens is when you're doing this type of development, it takes a long time. It really does. And again, it wastes a lot of time, people's time and money to do this kind of stuff. So what we're talking about is the new way that we're looking at doing things. And that is where you're still going to separate the different groups, but now each group works independently of each other. So let's say you have a big website and different people are working in different areas. Let's say I'm working on the shopping cart of the website. So I'm sitting over here. So I'm just working on my own little shopping cart. I'm doing the best I can, and then whenever they need to do an update or something, I'll just do my own update and send it out there. So as long as I maintain my communication with all the other software modules, they know how I'm going to send the data out, how I need to receive the data. I can just work completely independent from them. And I can do it a lot quicker. If they need an update, I can just go ahead, get the update done, and within hours or something, the app is updated and everything is working fine. So this is where we're seeing at SUSE where things are going. Whether it's containers or whether it's microservices, whether it's apps, this is how things are moving a lot quicker, a lot faster, a lot more independence. Any questions so far? You guys seen this on out there where people are starting to look at moving things outside and being more independent of each other? Yeah, okay. So again, this is what we're looking at, which is going to make you a lot more agile, and it's going to open the opportunities for everybody to get things done quicker and faster for the customers. Another reason this is the way it is because customers need some stuff right away. So if you need to get something done with the code, let's say there is some new way of doing something and you put it out there and you get feedback from the customer, it's a lot easier to make changes to it. Let's say it's not working. So all of a sudden, instead of waiting 6 months to change it, now within an hour or so, they can say, no, this is not working, let's take this module out and put a new module in there and see how customers react to it. So again, it makes you more agile and things move a lot quicker. And also, we're moving away from the traditional VMs. VM was a great technology, and it did a lot of help, back then, where you were trying to use most of the hardware. A lot of the hardware was being only used maybe 35%, 40% of its capacity. VMs came along, and it was great because now they're using 85, 90% of the capacity. But still, VMs were a little cumbersome, slow. Not to mention expensive, because every single VM you have to buy, if you're running, I don't know, Windows or something like that back then, you have to buy different licenses, different stuff for each one of those VMs. So now with the containers, you're more agile, everything is faster, quicker, and also more economical because you don't have to have a license for every single container that is out there. And then when it comes to growing or shrinking, depending on the customer needs, it's a lot easier and faster to do it. So let's start looking at containers as a service, as a platform. So the basic, what are containers? How many people here are using containers today or looking at using containers? Okay, good amount of people, good. So but the people who don't know, containers are basically an image that you're going to deploy, in this case, in this context, anywhere there's a Linux kernel running. So I create, as a developer, I create this small image of some type of code. Usually it's a simple code, something that does one thing. You create the image where you put the code, you put any libraries or every dependencies that code has. You create a container and then you put it out there. And it can be executed independently, or it could be part of a bigger thing. Like I was just talking about, let's say you have a website, you can create a container that has a shopping cart. And that container only does the shopping cart. And that can become part of a bigger application. So again, they can be built once and can be run anywhere. A lot of people, what they do is they would create these containers and put them in some kind of repository where people can access that. Let's say, for example, if I do my container of the shopping cart, I can share this with everybody else, so they don't have to write another shopping cart. Use this one. A corporation, for example, can standardize on a shopping cart. So every application that is going to be running on this enterprise will use the same shopping cart. So it gives them flexibility and also continuity. So it's the same shopping cart. Everybody knows what's going on with it. So then, again, why containers? The big one was a friend of mine told me this is a good one, to fix virtual machines. As I mentioned to you before, virtual machines, they were good. I'm not putting them down. I mean, the technology was good for its time. It was a level of abstraction. Instead of using one machine with one piece of software, now you can have the same machine with different pieces of software in there, and you can use most of those resources. So it gave you isolation, give you familiarity, because each VM had its own operating system, so they looked like independent machines to everybody, something that they knew how to use. Drawbacks, again, is the overhead. A lot of overhead. They were slow to come up, just like if they were in a regular machine. They weren't very agile. Like I mentioned, in the case of containers, you can kill one and bring one up within seconds, and the user probably won't even notice that the container was rebooted. Very low start, and like I said, kind of expensive. Depending on how many VMs you had, how many licenses or everything that you had to purchase for them. So what we're looking at in the container area is kind of like a fenced sandbox. It's a place where you're still going to be safe. Your app will be safe. It's not going to be interacting with other apps, but then it'll be a quicker, faster, easier to use. So it does isolation. It does have isolation built into it. We have some tools like chroot, unshare, so on and so forth to help with the isolation. You have the file space. You can mount stuff, bind stuff. You have some issues with people are still thinking about the security of the containers, and this is something that we're working all the time with it. It's still a little tricky trying to monitor containers individually, and also troubleshooting can be tricky at times. But again, that's something that we're working with different types of technology, getting through all these different issues. Questions? So the thing is that, okay, now you have a sandbox, you have all these nice little containers. Let's say you're working with 5 or 6 containers. Okay, so that's pretty easy. But once you start getting 100 containers, 200 containers, 1,000 containers, then things get pretty tricky. So this is where you need to manage that sandbox, that environment. So this is where CaaS comes in. You have a basic service, which is the Sun Micro OS. That's the OS that's running Kubernetes and everybody that's going to be running on top. Kubernetes doing the orchestration, the managing, the deployment is the one that's looking at the containers. One of them crashes, it brings it right back up. If you tell Kubernetes, okay, I need 10 more shopping carts. We're having a sale this week. Then Kubernetes can go ahead and create 10 more containers for the shopping carts. Once the sale is over on Friday, then you can say, okay, let's go back to the regular 2 that we have, and all that's done automatically. Tell Kubernetes I should have 10 containers at all time. So if I have one of the shopping carts goes down, then Kubernetes will fix it and bring another one back up. User interfaces, Horizon Tiller. This is you can do all the stuff in the command line if you want to, but we offer you also GUI interfaces, so it makes it easier for people who want to do things a little quicker, or they're used to using mostly GUIs. And then building these sandboxes, we try to make it easier and easier, either with Kubernetes or with Cloud Foundry. That's something that we're going to be talking about a little later on. So if you look at different areas where you would have containers versus not having containers, you'll see from this list that, for example, if you have an isolated development environment, you would have that without containers. With containers, it's more of a team thing. So you're going away from the silos in more of a team thing. You have your own little team and you interact with other people, but at the same time, you are independent, so you can move quicker and get out the apps quicker and faster. One of the big things is in the old days, if you have a proof of concept and you build it, and then when you try to put it into production, most times it would end up failing. And that's a problem because people say, well, it worked fine when it was on my system back in the lab. Why isn't it working now? That's one of the things that containers is taking away. It's the fact that you can create a container and pretty much run it anywhere because it has all the dependencies, libraries, and everything in there. So that's a huge time saver and just get rid of a lot of headaches. And then by using containers, then you give the developer the freedom that they can use whatever development environment they want, whatever they're more comfortable with. So by doing that, they can be more productive quicker instead of, now I have to learn this new compiler, now I have to learn this new editor and stuff, and it's going to take me a couple extra weeks. Where, in my old one, I can do this in a couple seconds, now it's taking me 5 minutes to do, so all that goes away. So if you look, this is a look at what like an Uber app would look like on the old ways, the monolithic, where you have pretty much everything in the middle and everything talks to it from the outside. It looks nice, but at the same token, it's an issue because if anything in here dies or locks up, it can potentially lock up the whole app. And then you're going to have customers going, this thing is not talking to me, it's not responding. So what we're looking at is moving things more, again, of an independent way where you have all your different modules sitting out here. They're independent of each other. If the payments module dies, you can go ahead and restart it immediately, and the customer doesn't even know that happened. So that's what we're looking at, just the flexibility and the robustness that the thing is going to be up all the time and running. So now specifically, let's go into the CaaS platform. So basically, it's a container management solution. As I was talking to you before, when you have 5, 6 containers, it's really easy to manage them, to keep them up and running, to check them out and stuff. But when you get into the hundreds, 200, 300 containers, things are getting pretty hairy. So this is what the CaaS platform is going to give you. It's going to give you a platform where you can deploy, manage, scale, and do all this stuff. So especially with specifically with containers. So this is what the platform looks like. You would have the micro OS sitting as a foundation down here, and then on top of that OS, you'll have the different things. For example, all the automation and stuff, we're doing it with Salt. This is something that you're going to also find out. You're going to see Salt everywhere within SUSE. All the different products, we're standardizing on it to do a lot of the management and configuration of, in this case, of the containers of the different nodes. Then on top of that, you're going to have storage. Everybody needs storage, whether it's just storage while the container is up and running, or whether it's persistent storage. You need something that is going to be sitting there. The container can go up and down, but the storage will stay there, and the container can access it later on, and it'll still be available for it. Networking, of course, you're going to need some kind of networking. The nodes would have their own network within them so they can talk to each other. And then you have the option of adding an external view for the network. Let's say you need to have this node access the internet and get some information or whatever, then you can give it an IP on the fly, and then the system will take care of doing that for you. Registry, we have a registry that we created with the containers, and this is for you to store those containers and maybe make them accessible to other people within your organization. Also, you can create groups. So you have certain containers only available for the people within that group. So if you don't want other people, to take a look at it. What this gives you is the ability of having containers that have been tested, that have been proven, that you know where they came from. So it's not stuff that people just downloaded from the internet. Oh, yeah, this is a pretty cool container here, and it says that it can do all this stuff. Well, yeah, but you don't know who developed that thing, and maybe has a backdoor or something that you don't know about. So this gives you an area where you say, okay, these containers were created here. We know who created them, we tested them, and they're safe. And then stuff like security and logging, everybody has that in there. So we also have that as part of it. So the orchestration at the top is basically done by Kubernetes. Kubernetes is the one that takes care of, as I said before, creating, managing, deploying, updating, killing containers, restarting containers. The updates, for example, are done at that level. You just go ahead and kill the container and put the new container with the update in it. And it just happens so fast that people don't even notice that it happened. And then all the different services that you can create through Kubernetes and have the containers using different services. Yeah? No. I thought somebody had a question.
Why are you've got some boxes red, some green, storage, security, logging, are they different?
No, this is just like the area that runs within the micro OS, and then this is the stuff that Kubernetes brings up. So it's just two areas that are on top of each other.
I think, I don't know who was referring to, but the persistent storage, security, and logging boxes specifically, those three are gray, right?
Okay.
The rest of them are green.
Yeah. Tell you the truth, I think it might have been a marketing thing. They just give it a different color. It's. Mm-hmm.
These are the parts that are not an integral part of CaaS. So storage comes from external.
Okay.
Logging needs to be external. It's external. And
Okay.
security also. So to
Kubernetes is pluggable.
review containers must come from
Okay.
provider.
Thanks for
Okay.
clarifying.
Yeah, thank you. You see, you learn something every day. So there's three key technology components that make up CASP. Basically, you have Kubernetes, the Sun Micro OS, and the container engine and Salt. So again, Kubernetes takes care of all the orchestration of the containers, everything has to do with, again, the deployment, creation, management, so on and so forth. So Sun Micro OS is the foundation. That's where everything sits on top of and provides you with all the OS things that are needed for the containers to run. And then Salt and the different engines take care of all the configuration of the containers, how they're set out and so on and so forth. So looking at the micro OS, as I mentioned to you before, that's basically the foundation. That's where everything builds upon. Some of the key features, it's a very, very nice, very, very small footprint OS. It basically has everything the containers need and none of the extra stuff that a regular full-size OS would have, which makes it, again, very quick, very agile, very small footprint. It is especially, again, made for doing containers, and it has all the core technologies that come with the operating system, which has your file system, ButterFS. You can do updates and everything using RPMs, AutoYAST, etc. It can scale up to thousands of nodes, so that gives the ability of being flexible. And also, as I was mentioning to you, you can do a transactional atomic updates with this type of OS. The next one was Kubernetes. As I mentioned to you before, they take care of deploy, management, scale, and the clustering of all the containers for you. This is how you can deploy that large number of containers thanks to Kubernetes. Kubernetes takes care of looking at the containers. You can set up parameters for Kubernetes to look after. As I mentioned to you before, let's say you want 10 copies of this thing at all times. It'll make sure that the copies are there. So if they're not there, one dies, Kubernetes will jump in and bring it back up. So that's the function of Kubernetes. Deployment. How many people have tried installing Kubernetes from scratch? Well, I haven't done it, but I work with people who have done it, and they tell me that it can be a nightmare. That's one of the things, that's one of the value adds that SUSE have brought to Kubernetes, is the fact that you can install it very easily, you can configure it very easily. We have everything done in the GUI, and I'll show you that at the end. It's very easy to update, to manage. And so we've taken a lot of that pain away. We've made a lot of assumptions and stuff when you're installing it, so you don't have to worry about every single parameter during the installation. And once it's up and running, it's really easy. You can have a Kubernetes installation in average, I don't know, 15, 20 minutes, using CaaS, and you'll see that at the end. So it's very easy. You have to have certain knowledge, but you don't have to be a super guru to do it. So it makes it, again, easy for people to do it and to play with it. So if you look at our configuration, you're going to have the admin node. This is something that we added. This is the one that brings everybody up. This is the first node that you bring. And then you have all the Kubernetes nodes, which will be masters and workers. The masters are the ones that take care of the worker nodes. They figure out where to send the different things. If one crash, bring one up here or bring it up here, or that one is having a problem, so on and so forth. And then you have the worker nodes. Those are the ones that actually run the container. So this guy is bringing up the masters and checking out in general the system. Then the masters are checking all the nodes underneath them to make sure that the cluster is healthy and everybody's running. And then each one of the workers will run a container. So again, if you need to grow your system, let's say you need 10 more containers, whatever, then the workers will be the one, extending or shrinking the system as it needs to. So this is the Kubernetes part. And this will be the part that kind of SUSE added to it to make it easy to install, deploy, etc. Any questions or?
Completely off the wall, but this looks very similar to the way enterprise storage works.
Mm-hmm.
You've got the monitors that monitor the OSDs. And
Right.
They kind of
Right.
things around. Is that kind of the same thing we're talking about?
You have these are the guys doing the monitoring. So I guess you can say maybe these are the monitoring nodes, and these are the OSDs in the case of storage. I guess you can say yes. It's a similar architecture in that case. Okay. So this is the roadmap. We're sitting right around here on version 3. We'll be coming out with version 4. Right now, we're sitting at Kubernetes 1.10, and we're looking at is as we go along to get closer and closer to the Kubernetes releases to keep up with all that stuff. We are running right now on 12 SP3. The next one we're probably going to start running on 15. That is out. So as you see, there's a lot of stuff we're going to be adding to it. So if you guys have any ideas or any things that you would like to see, feel free to contact any of us. We got a lot of the guys even here in the room that can listen to you if there's some particular function or something that you're looking for. We'll be more than happy to listen to you. Any other questions on CaaS?
We are now on 3 updates.
Yes, right here. Okay, so let's talk about CAP now. So what we've done is we've taken Cloud Foundry and Kubernetes, and we have brought them together. I think I better go to this side of the room. We have containerized Cloud Foundry, make it easier, faster, and much smaller footprint, basically. So again, Cloud Foundry, we've taken the developer experience of Cloud Foundry. We have containerized, so it's easier for people who already know about Kubernetes, and they like the ease of Kubernetes and the flexibility that Kubernetes had. And maybe they were looking at something like Cloud Foundry to do more of the higher level thing, and I'll go into some detail on that. Also, people who were in Cloud Foundry who wanted to maybe learn Kubernetes and stuff but didn't have the time and everything, now they pretty much don't have to, because Kubernetes is all put together and embedded into the Cloud Foundry. It's a much smaller footprint than the regular Cloud Foundry, easier, faster, 100% open source. Everything that we do here at SUSE is open source. And of course, enterprise-grade Linux. So this is something that we support 100%. You have a problem with it, you call SUSE, and we'll give you the support that you need. So if you look at Kubernetes, and I think I mentioned this on the previous slides, it's aimed mostly at operators, not developers. By that I mean, when you're using Kubernetes alone, you're pretty much doing the container part, and you're doing these little pieces. A lot of people will take those little pieces, either run them individually, but most of the time they will, let's say they'll take the shopping cart, they'll take the payment and different things and put them together and come up with an app. How many people here are familiar with WordPress? Everybody use WordPress? The way I kind of got this thing into my head is, you have WordPress, which is your basic blog. People can use it as a web servers, whatever. But then you have the plugins. So you have all these different plugins. For example, I have a website where I'm selling different things. So I have a plugin to do the shopping cart. I have a plugin to do the payments. I have a plugin to do whatever. So you may want to think about Cloud Foundry would be the WordPress, and then the containers are the plugins. So they are independent, and then they come together, and then they create. In this case, you can have a blog with WordPress, or you can have a website based on WordPress. Does that make sense? So you see now the analogy that I said, the containers are a little different than applications. You can run these things individually, but also you can put them together and add them and create this great big app. So what Cloud Foundry is going to give us is the ability for the developers to make their life easier. So what you do is you take in this case will be an app. So it'll be like a WordPress with all the plugins and everything in it. And then it's going to containerize, deploy, and manage that application. So what it does is you create the code. As a developer, I just have to do the code creation. And I give it to Cloud Foundry. Cloud Foundry looks through the code and says, oh, this is Java, or this is Ruby, or whatever. And it figures out the libraries and everything that it needs to pull in, puts everything together, sends it out, and then I think it's called a droplet, and then that gets containerized and it gets sent out through Kubernetes. So as a developer, the only thing that I have to worry about is my code. How to do the networking, how to do the libraries and stuff. Cloud Foundry will take care of that. So it makes my life a lot easier. I don't have to worry about that. If you look even at the container side of the house, when you do container, you have to figure out the libraries. You have to figure out the dependencies and stuff to put within the image of the container. In Cloud Foundry, you don't have to do that. So it gives you, takes out that from you, although that also takes away a little bit of the flexibility that containers, because containers you can because you make the decisions, you can use different versions or different tools or different things. So this just makes your life a little easier. If you don't want to deal with those little things, this is going to give you a lot more leverage and power.
I think it's easier to say it's a point of abstraction for the platform.
Yes, that's a perfect.
That's what it's saying.
Mm-hmm. Yeah, it's
Point of abstraction. You don't need to care about that.
Exactly. You would have containers here, and this sits on top.
Yep.
Like you said, it's a higher level.
Yep.
Exactly. Any other comments, questions? So then it also automates the lifecycle management. Again, it takes care of all the resources and stuff, put them all together, and sends them out for you. So, exactly, and this is the one that I worked a lot trying to figure out what is Cloud Foundry. Why is it different than CaaS? Basically, it's a platform as a service. As I mentioned to you, it does a lot of the I don't want to call it smaller stuff, but the simpler stuff that you, as a developer, sometimes you don't even want to be involved with. It will take care of it for you. It's mostly for cloud-native applications that, again, will figure out how to do the routing, how to do the libraries and everything for you, so you don't have to worry about it. It was originally open sourced by VMware in 2011. And if you want more information, you can find it at cloudfoundry.org. Okay, so I love this slide. and again, this is another way of thinking what's the difference between CASP and CAP. So when you're talking about container as a service, basically what we're providing is the electric, the oven, and the fire. Now, when it comes down to the pizza, you have to provide the pizza. And by that I mean you bring whatever dough you want, whatever sauce you want pepperoni, you want ham, you want pineapple, you want whatever. You bring all the ingredients that you want, that you feel more comfortable with. Maybe I like this sauce a little better. It tastes better than that other sauce, or etc. So you're responsible for all the different ingredients to make that pizza to bring to the party. Be your friends and conversation, whatever. That's always going to be different. We can't bring you friends. We can't bring you conversation. So when you talk about CAP, we are now providing you the pizza. We're the Domino's. You call Domino's, I want a cheese and pepperoni pizza, and we'll bring you a pizza. We make the decision of what sauce we're going to put there, what pepperoni we're going to put there, what ham we're going to put there. So this is where you see there's a difference. You don't have that flexibility that you have when you are making the pizza, and you can choose the sauce. You can choose that. But on the other hand, it reminds me of, for example, McDonald's. One of the things that McDonald's does is they want to make sure that their hamburgers taste the same anywhere in the world. So when you go to a McDonald's anywhere in the world, you know how that hamburger is going to taste. You expect that. So that would be this level. So we're giving you that consistency. We're giving you that, you know the libraries that we have in here. You know the compilers and everything that we're going to be applying to that code. So it's easier for you to do that and let us do all the other stuff. Does that make sense? So remember, every time anybody asks you what's the difference between CASP and CAP, you tell them it's the pizza. Got it? Okay. So this is what I was telling you about when it comes to building software using Cloud Foundry. You would have the source code. You send that source code to the staging container. Here's where Cloud Foundry comes in with what they call build packs. There's different build packs for different source code. If it's Java, if it's Ruby, if it's whatever. That's going to bring all the dependencies, all the libraries, all the stuff that you need. Again, that's the stuff that's your sauce, that's your cheese, that's your pepperoni. But that's the one that we're providing to you. You don't get to choose the pepperoni, or the version of the pepperoni, the version of the sauce, whatever is the one that we have. And then the rootfs, file systems and stuff, whatever, bring it all together, and then it comes out as a droplet, which is a Cloud Foundry term. And then after that droplet comes out, it gets containerized, and then it becomes an app. And then that's the app that goes out, whether it's a phone app, whether it's a web app, whether it's whatever type of app. At this point, then Kubernetes takes over. And then Kubernetes handles this as a container, because it's an app within a container. So to Kubernetes, it looks like a container. So same way it handles it, it grows it, shrinks it, kills it, updates it, it does whatever it needs to do with it. So do you see where we have done, this is the Cloud Foundry part, and this is the Kubernetes part, how we brought them together to make things easier. So you have the easy of the Cloud Foundry over here, and then the management stuff of Kubernetes over here. So if you really want to look what goes inside all that stuff, that's basically it. But you don't want to do that. You want to look at this. It's a lot easier. So if anybody asks you, say, yeah, there is a lot of stuff going on in there. But you don't have to worry about it. You can look at it from this point of view. You have your source code. You give it to Cloud Foundry. Cloud Foundry gets everything that it needs for it, puts it out in a droplet. Kubernetes containerizes it, and it goes out. But don't forget the pizza. So once again, applications are not containers. It's a higher level of abstraction, like the gentleman here mentioned. Applications can use containers as part of the application. You can build it just like a container once. It connects to different services, whether it's internal or external. So you can scale it. You can route to it. You can do all this different things, and there's a way of managing the life cycle. So Cloud Foundry understands the world from the application point of view, as I mentioned to you. It does the application, brings everything, and it sends it out. And then Kubernetes takes care of it from the container point of view. So if you look at everything that goes on the CaaS platform, once again, you have all the different things underneath it, the Kubernetes, and then you actually have, I believe CASP is included in CAP. And then you'll have your control plane where you have, kind of like we mentioned before, the logging, the APIs router, the different storage and stuff. And then you have all the different workloads that sit up there. And then Kubernetes will take them and use them as containers. This will be containerized.
That was a question that I've been thinking all along, is that you've got the CaaS and you've got the cloud.
Mm-hmm. Mm-hmm.
And
So
Kubernetes.
exactly, Kubernetes is the thing that ties them together. Exactly.
Essentially, when you add cloud, you still have the CaaS platform available for the operations side.
Mm-hmm.
You don't need to buy CaaS separately. You don't need to install separately, or is it just really?
Well, it depends. If you're going to be using, because for example, I have customers that all they do is containers. For example, they will do a shopping cart. They will do whatever. They provide that, as I said with WordPress, it's a plugin. I provide you the plugin. However you're going to use it, it's up to you. So if you're somebody who's just going to be developing or deploying whatever containers, then CASP would be your platform. Now, if you're going to be using applications who might use containers, then that's where you would have something like CAP that has CASP underneath it, doing all the container part, bringing the containers, then you bring the applications, give it to Cloud Foundry, and then goes out the other way.
CaaS is not exclusively a container.
No, exactly. CAP is not exclusively, CASP is exclusively container. CASP is not. CASP is applications who may use containers. They don't have to, but some of them do. Again, containers are becoming so common use that a lot of people say, again, why am I going to code a shopping cart if I can use a container that I bought somewhere or whatever?
There's a monolithic application.
Yeah, exactly. So if you look at the cloud platform, this is where we are today. 1.2 is coming out. Actually, we're just about to come out with 3, correct?
That's actually, that's way out of date. It isn't your fault, but
Okay.
so it's,
I was told that was the last one, the latest one.
it's heavily updated 2 Fridays ago, I think.
Oh, okay.
Ron Newman from the product management team will be giving a roadmap presentation for folks.
said, it's now called 1.1. So that's SUSECON press release today, and version 2 will be later this summer. And a lot of those details have changed.
Okay. Thank you. So to wrap up, it's kind of like we were just talking before. You're going to have the CaaS platform, which is mostly the container part. And then you're going to have CAP, which is your applications, who may use containers as part of the configuration of the app. So containers only, and this application with containers if you want to do it that way.
So it brings to mind, generally you're going to have different like you said, you have a development environment, test environment, proof of concept environment before you go to production anyway.
Mm-hmm.
So, but if you wanted to apply some of the CaaS stuff onto an existing CaaS platform, would they integrate, or is it just going to be entirely different?
No, they will integrate. Yes, yes. Like I said, you can have CASP as part of CAP, or you can start with this one and then eventually move to that one. What happens is all the containers and everything that you create with either one of them, let's say you create a bunch of containers. Let's say you start with CASP, and you create all these containers. And then eventually you're like, okay, I want to go a little higher to create the applications and stuff, and maybe using some of these containers. You can install this, and all the containers and everything that you created with this will run here. So you don't have to like redo them or no. They will work just fine.
And then you've got your CaaS security for the back of it, and you do the CaaS will.
Yes, exactly. Mm-hmm. Yeah, because like I was telling you, the repository and stuff will be down here.
Yeah.
And then this uses what this one has.
So if somebody wants to publish for CaaS,
Yes.
they would have to have the proper permission.
Mm-hmm. Mm-hmm. Mm-hmm.
Could I use anybody's CaaS platform underneath it? I mean, if I run
Yes.
one EKS,
Right. This will run on SUSE, but it would also run on the cloud. If, like you mentioned, the Azure or the AWS, then you will use their Kubernetes part, and then you put this on top. Mm-hmm.
So, like for example, you could have, a typical customer would have maybe do some quick dev testing, right? Have and so forth. Then when you're ready, you can bring them back in house. So you your security certifiers.
could I dual home it? Could I have one instance of CAP that could have multi-home? I might deploy some to public.
Correct. Yes, exactly. Yeah.
Right.
You're supposed to have the same experience of the application.
My developers
Yeah,
go
exactly.
to one place. Who cares where they don't care?
Exactly. Exactly. And again, that's the beauty of the containers. You deploy them in one place, and they run everywhere. Okay, so again, to put it all together, when you're talking about containers and stuff, CASP. And then when you talk about the different build packs and stuff, doing the whole application thing, that's where you would go to CAP. Again, kind of like going back to the pizza thing, you bring all the runtime images and stuff that you're going to put on the image for Docker. In this case, the platform gives you all those things. So it gives you a higher level of standardization when it comes to all the dependencies and the libraries and the stuff that are running underneath. And at the same time, it takes that away from the developer. I don't have to worry about the libraries and stuff. It'll take care of it when it goes through the Cloud Foundry part of it.
I guess I'm not as familiar with the Kubernetes, but I'm assuming that there's a CO application container. There's a repository for the containers you have.
Yes. Yeah, the repository, like I said, there is there are several repositories out in the internet, but our CASP platform has a repository where you can use. Let's say you get a container from a website, whatever. You bring it in, you test it, you check it, make sure that there's nothing weird with it, whatever. Then you can put that on your local repository. So then you tell your people, your developers, everything on this local repository is safe. You can use it. We support it. Whatever. Please don't. If you want something from outside, let us take a look at it before. But don't bring anything. Just use this repository. That way, you keep control of the containers and stuff that are being used. They're safe. They've been vetted. They've been QA'd. Whatever. You can enforce that. And by the same token, with the repository, you can create, let's say, groups, because you may or may not want to have all the containers available to everybody. There's certain containers that these guys will only use, and containers that these guys will only use. So you create the different groups, and the people belong to different groups or whatever, so they have different access to the different repositories. Well, that's what I had. Again, I apologize. I don't have the demo, but we got a couple minutes. Let me show you. When you install CASP, and this is basically installing the Kubernetes, I just want to show you how easy. It's really, really easy. And again, if you have done Kubernetes before, you would realize this is very easy. So you come in, you boot up from the ISO. It's going to ask you basically the root password, whatever password that is. It's going to ask you for your registration code. That's the one that you get from SUSE when you purchase the subscription. Or if you do a 60-day eval, you get that registration code. It's going to ask you where the NTP server is. There could be any server out there. And you click install. Then it does its thing. It's going to take a couple minutes and stuff, and then comes up. You go to your browser. It's going to tell you where. Go to the browser, go here, and then the first thing you're going to do is you're going to create an account. So in here, you are creating the account. It's going to ask you for some settings, like where the dashboard is going to be at. You want to install, most of the time you want to install the tiller. That's going to give you some other capabilities. A lot of times, if you just want to do a simple installation, just basically hit next, take care of all the other things. Now the next thing you have to do is bootstrap the whole platform. So it tells you some things in here, some tips on things that you want to do. You hit next. Usually, at this moment, it's not going to have anything in here because this is just your admin node. Remember, you have the admin node and then the worker and the master nodes. So it'll come up here, and then at this point, that you go in and you create all your different nodes. Eventually, once you've created the nodes, you come back here, and then the nodes will show up. And then you will say, most of the time you say accept all nodes, because you just created all those nodes. You can accept them. And then it's going to go into, okay, it's going to be a little progress. This one takes also 5, 10, 15 minutes, depending on how many nodes you have and everything. And then it comes with this screen, and it comes with unused. And then here is where you tell the system which ones are going to be the master nodes and which ones are going to be the worker nodes. A lot of times what I do is when I give them the host name, within the host name I'll say master dot ba 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 or worker dot ba 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 ba. So it just makes it easy, but you can do it anything you want. So in this case, they used all workers except for that guy, made it in a master. And then you hit next. Now everybody's set up. You're going to bootstrap. It's going to ask you for the outside address for the Kubernetes, and then the external and for the dashboard where they're going to be at. You bootstrap your your cluster, and then it's going to go in, and then you'll see these guys kind of going around. It's setting everybody up. It's setting the network. It's downloading the whatever software for master, software for worker, etc. Goes through the whole thing. When it's all done, it's going to give you all these check marks saying, okay, everybody's up and running. If there's a problem, you probably get a little X in red saying, no, this guy didn't boot or something. Maybe you want to redo it again. But in a perfect world, you get all your check marks nice and green. And then at this point, you want to download your configuration file, because that's the one that has all the information that your system is going to need. So every time it accesses this network, it checks that configuration file so it knows where things are, who is who. So you bring that guy down, and then you basically come back and log it into your account, and you're ready to go. It's going to ask you to, again, make sure you download the file, and you want to put it on your squiggly cube slash config. That cube config becomes config, so you have to change the name. And at that point, you're up and running. You got a network going. You can start sending, and that's unfortunately that's what I wanted to show you, how to send the different loads to the system and having me create all the different things, and you see it up and running. Well, guys, that's all I have. Any questions, comments? Well, thank you very much. There are a lot of other sessions that would go a lot deeper. This one I just wanted to talk about in general what CASP and CAP are, how they differentiate, and how they complement each other, and I hope I did that. So again, thank you. There is a survey, so make sure that you run that. Also, the survey is going to give you points towards the prizes at the end, so make sure you fill the survey. And everybody got scanned when they came in? Well, this lady over here, she's going to scan you on the way out then. Well, guys, thank you very much, and I hope you enjoy SUSECON.